Welcome, my name's Adam Taylor from the Keira Proctor Group. I'm the Business Development Manager looking after facade and high-rise building design. Today we're going to discuss treating airtightness within the building envelope. We're going to discuss more in details the design considerations, the building regulations, the challenges of airtightness within a facade, the specification, the important parts of fire, case studies and the Proctor Group services. Design considerations when looking at facade and envelope design covers the air and what we call the vapour control layer. So looking at where a vapour control layer is actually input into the fabric or whether an external air barrier would be more suited. So we're going to challenge that and actually look at internal vapour control layers for high-rise development. Are they still suitable for high-rise? Are they actually redundant? Do we need them at all? Are they a liability? And do we rely on them too much for airtightness and for vapour control? Vapour control layer is important to us, but it's the penetrations that potentially are put through that product that means it's not doing its job. So today, the focus to look at Airtight externally into a facade design is more important. The information we gather to look at these regulations and how we look at treating buildings correctly are all the guidance documents that we use. So we use the documents of the building regulations L and F for ventilation. All of these look at different ways that we can treat a building. And importantly, we also look at approved document B. The first thing we look at is the building itself. Is it a concrete frame or is it a steel frame? Within concrete construction, you have a higher drive of condensation through temporary drying out periods. Concrete can take many years to dry out totally. That has an effect on the building itself. The second phase of looking at design is the weather. Now we use an analysis that looks far deeper into generic monthly averages of weather. We use something called a WUFI analysis, and we'll look at that in more detail coming up. The next phase is to look at the occupants. Are the occupants residential? Is it a commercial building? Is it mixed use? Is it a student accommodation? Again, these vapour drives can be differently from these markets. So if you've got a student accommodation, we would see a higher internal moisture risk. We then look at how the building's heated, whether that's gas or electric. Again, the heating systems work differently and the air quality can be different. We then look at the important factor of an airtightness on a building. So an airtightness model on a building, the more you make it airtight, the better energy efficient it becomes. But because you've got moisture in the air, you've got heating, cooking, etc., with a more airtight building, you have a higher risk of moisture. That's where our key principles, the HAM principles, come into action: heat, air and moisture movement. Now the WUFI analysis is something that looks at a building in a far more detailed factor. It looks at the internal line of the frame of the building, the plasterboards internally, the sheathing board, the membranes you can use, the insulants within the products, and finally the external part, the rain screen, or the brickwork that's on the external of the building. Even the changes in colours to these products can make a difference through solar radiation. WUFI analysis is a way of looking at how the weather affects a building. So it takes into consideration the temperature, how much humidity is in the air, and what humidity means to the building internally as well. Now we input this data, which is gathered by the weather satellite, for a minimum of 5 years, 24 hours a day. This gives us a totally different look against the standard glazer methods of when people are looking at condensation risk. You would normally look at a condensation risk as part of your U value. And you're given 12 graphs at the back of your U value that tells you whether you've got a condensation risk or not. The WUFI analysis, it gives you a lot of data and a lot of graphs that shows that it can have a better effect on a building. We are seeing concrete frame buildings drying out quicker with the removal of a vapour control layer. Now when we look at WUFI analysis, depending on the balance of insulation, whether there's more externally than internally, we can actually remove the vapour control layer totally, allowing for a quicker install of facade. Now when we think about a vapour control layer and the way it's installed, it is installed at the dry lining stage, so it is normally taped to a track and stud system that's installed around the perimeter of the building. This is fine. In its instance, it is normally taped, and we do all the details for that. As a manufacturer of vapor control layers, we actually know these details well. We've gone forward and moved our vapor control layers to being fully reinforced, not allowing for tears or rips where penetrations are made into it. If we look at what we put internally into a construction these days, light switches, sockets, data networking cabling, sprinkler systems, air conditioning units, plumbing, sanitary, all of these potentially are going to penetrate through the vapor control layer. Now that is where the problem for airtightness and condensation control is a risk. Now we normally see products available on the market, as in back boxes to switches, that you can tape the vapor control layer to. Realistically, the people installing these switches and electrics and plumbing are not aware of the importance of what a vapor control layer does. So by removing it totally, we remove the risk of leaking, the risk that it won't get to an airtightness that we'd want to see in modern day methods of construction. If we look at the external of the building and we look at the concrete frame and the SFS infill that goes into a high-rise development, what we can look at is a breather membrane that's normally installed. We have many membranes that have been installed over the years, and our biggest problem with that was the same as the detailing for internally. Unfortunately, these membranes are normally mechanically fixed or taped into position. Now on a low-rise building where you normally see plywood decking boards or OSB sheathing boards, mechanical fixing is fine. Using a stapling system, you can penetrate and hold the material in place. On a high-rise construction, we're normally using a kind of non-combustible, A-rated fire product, sheathing board. That's magnesium oxide or cement particle, normally A1 or A2 rated. These are a very robust board that you would never be able to staple in. So we're more reliant on tapes to hold the membrane in place. Now the problem with this is the tapes realistically are only as good as they're put on, and the problem with being a tape is that the material in between it may bellow. And we're talking about high-rise developments, so over 18 metres ideally, so you will get a lot more wind movement, which means these membranes move around a lot more, they can tear easier, they can come off the construction. What we've introduced today with Airtight is one of the first fully adhered breather membranes on the market. This means there isn't an integral tape, it is fully adhered. So you are literally peeling off the lining paper and sticking it to the building. It's almost like wallpapering. Now, when we think about using it this way and how we detail differently with Airtight, we can see the improvements of airtightness. The reason being is, being on the external of the building, there is very limited penetrations that are being cut into. The frame stays in the same position, and the SFS infill is there as well. So the positions of air conditioning units or anything else that penetrates through it, we already know, and we can treat it easily from the external. Now when we think about airtightness and a model for airtightness, I'm really going to push the boundaries of looking at how to model differently by using airtightness within a SAP or SBEM model. What we're going to look at now is Airtight against traditional system of installing membranes. And this is a typical air improvement from 5 air changes per hour to 3, and how it developed into a system that allowed a construction to go ahead without changing the footprint of the building. Now what we'll start with is the internal. So the internal VCL was removed from the construction. This was based on a WUFI analysis and allowing us to see that there wasn't a condensation risk even with that vapor control layer removed. We then downgraded the sheathing board. As we were being applied to the sheathing board, this meant we could use one that wasn't as watertight as what was required initially. The biggest change that was driven by this specification was to reduce the insulation thickness, not the actual specification of the insulation. But this project was initially designed before the unfortunate events of Grenfell. And following on from that, the changes in this construction were required to move from a limited combustible to a non-combustible material. The initial design was using a far superior thermal value product, but we needed to look at moving that to a non-combustible product. and normally this means that the thermal conductivity is generally worse. The product was 120mm thick originally. When we looked at using a non-combustible mineral wool, it moved to 180mm thick. This wasn't sustainable for the construction. So what we did was change the airtightness that had been modelled within SAP. This airtightness originally was 5, and we changed that airtightness to 3. What that allowed us to do was actually take a lower U value in the construction and actually install 125mm of non-combustible mineral wool and still keep the same energy efficiency of the building. That was a key driver for this project. But while we were doing that, we found all the other parts that we could save money for the construction and make it a far simpler design and a far superior for weather tightness and condensation. Now, once we'd finished changing the insulation, we looked at the EPDM that's used across the project. We use a lot of EPDM around window frames. Airtight, being fully adhered, can stick to concrete, steel, sheathing boards, and many products. So what we do with it is actually wrap it into the frame of the building before the windows are installed, giving a nice airtight and watertight line. But what it also meant was we could reduce the amount of EPDM on the construction around these openings. We then moved to the frame of the building. Now again, the frame was designed with EPDM to be installed across it. With the use of Airtight in its place, this meant that this could be eradicated from the building and save much cost. A standard Class B membrane is normally installed, but what you'll see is there is an uplift in price with Airtight, which you are not using any tapes. You haven't got to try and keep mechanical fixes in place, and it's the amount of EPDM that you've lost from the construction, meaning the building breathes better and is healthier, quicker. We use a simplified expansion joint detailing around any openings or any jointing that's required. Any movement joints that are needed to allow the product to move means that we can design that quite easily. Again, we've got the reduced EPDM flashing depth and the simplified corner detail. Simplified corner detail is actually a prefabricated corner that we can manufacture in many sizes, allowing you not have to design and try and treat on site. As you can see, there was a great saving to be made even before the labour was included on this project. As this was originally designed just to change the insulation, since then we've moved forward quite a lot and we're seeing non-combustible mineral materials already within the cavity. So what we've done for this exercise is actually remove the price of the insulation. As you can see, that saving is quite dramatic. When we look at specification for breather membrane, the biggest problem is there is a multitude of different ones on the market, all doing something totally different. The BS 5250 clause only looks at vapour permeability. But when we look at materials that comply with BS 5250, we have Airtight. Now Airtight complies with BS 5250. It is totally vapour permeable. It is airtight and it is liquid tight. It's a watertight to W1. The difference with vapour and air is the size of the molecules. That is why vapour can still transfer through, but we can class this as an airtight membrane. But interestingly enough, one of our market leading products, Roof Shield, is totally air permeable. So this allows air traction through, designed specifically for pitch roof applications, but still is vapour permeable and liquid tight. So now you can see we've got two totally different products doing two totally different jobs, but also complying both with BS 5250. The simplified way is to get in touch with us so we can make sure that you get the right membrane in the right position on the construction. If we think about a vapour control layer, a vapour control layer is airtight, it is watertight, and it is vapour tight. But that is while it's in the position of a full sheet, not affected by the penetrations that we see many times in construction through it. That is why we don't class it as a vapour barrier anymore, but a vapour control layer. Now, one of the biggest challenges in the market at the moment is fire. And this is something that we need to look at when looking at high-rise design and facade design. Now, we had an approved document B 2006 and an amendment looking at buildings over 18 metres, what could be included or excluded from that facade design for being non-combustible or combustible. Changes just coming in at the end of December 2018 has allowed us to look at membranes over 18 metres more specifically, and this has been written into the clause in the building regulation changes. This now states that you can use a Class B S3D0 membrane on construction over 18 metres. The difference between trying to manufacture a combustible or non-combustible membrane comes down to the actual material that it's applicated with. We're seeing in the European markets people offering A2 or A1 rated membranes. However, the significant difference is these materials don't actually breathe. The breathability comes from using parts that are combustible. So that is why the regulations have recognised that Class B is an acceptable product and won't offer too much of a calorific value or spread or fuel the fire much more. Now when we look at the BR135 mechanisms of fire spread, we've got two challenges: the rapid fire spread and the restricted fire spread. Rapid fire spread, initial fire develops and flashes over. This is where it flashes up the building, on the outside of the frame. Restricted fire spread is when we see secondary fires being driven internally to the next floor, and will only ever repeat that process by going floor to floor rather than up the outside of the building. Now when we think about breather membranes on the outside of a building, we've got two different ways of fixing these membranes back to the sheathing board: mechanical fix and tape, or fully adhered. If we first look at mechanically fixed membranes, and if we look at the external surface being ignited, we then got a gap that oxygen can flow behind the product. What this means is there's a secondary ignition and a higher energy release, meaning the product burns quicker. This may offer further calorific value and higher fuel to the fire. If we look at a self-adhered membrane, this is fully adhered back to the sheathing board and the frame of the construction. If we look at igniting the external surface, but actually because it's fully adhered, there is no gap, no oxygen to travel behind the product. There is a reduced energy release, meaning the calorific value is certainly a lot less than a mechanical fixed product. Again, we look for guidance through Approved Document B, BR135, and Section 2 Handbook as well for Scotland. All of these state from December 2018, when the regulations were changed, that you can use a Class B membrane above 18 metres. But we offer significantly a lower calorific value by using a fully adhered product. Some of the case studies we've already got on the market show how Airtight is installed. It shows how it's fully adhered and wrapped around the construction. You can see it in place with insulation and bracket systems. As we penetrate the membrane, with help in hand brackets and other fixings, the product will actually wrap around the fixing through it, this allowing for almost self-sealability. This is a short clip of a project in Portsmouth on an extremely windy day. You can see from the scaffold sheets and the flags how much wind was blowing. But you can actually see that Airtight, once fully adhered, doesn't move. This allowing for site to carry on other jobs on that day rather than getting back up and trying to retape joints. You can see the brackets penetrating through as I described earlier. On this project here, these are concrete thins that was originally designed to be used with an EPDM membrane system, not allowing the concrete to dry out in as much time. As you can see with the Airtight fully adhered system, this allowed the building to breathe more but was still totally airtight. Here you can see our corner detail, where we've wrapped around into the frame of the building onto the steel stud. You'll see that the corner sits behind this. The corner is a slightly different colour, allowing us to see whether the corners have actually been installed correctly or whether it's been a tape version. You can do either, but the corners are prefabricated and certainly a lot quicker as part of the system. We've introduced a liquid applied breather membrane for roundabout details where we'd see a high risk of condensation, where normally would be treated with EPDM. This product seals and watertights it, but allows the product still to breathe. We now see a limited amount of EPDM around the construction of the windows. Now we can see that the EPDM, because of the way it's layered, with a glue system, a primer, two-part adhesive and then a rubber, it can be quite messy. So limiting the amount on this is better, and better breathability in risk of condensation around windows is normally colder. So by limiting it around windows, this will allow the condensation risk to be lower. The product itself is being used well in modular offsite construction for being fully adhered in factories and allowing it to be transported watertight to site. Here we have a college building that's going up, as you can see, fully adhered off a cherry picker, allowing the product to be wrapped easily on site. And this is a major project in Twickenham, again showing the residential use. We look at the technical support services that we offer. The first one being the amount of drawings and detailing that we can offer the project. We will take a flurry of drawings and design everything independently. Whether we've done that detail before or slightly different, we will look to make sure if there is any differences that it is lined and the product is positioned onto the drawings, allowing site to install correctly. We run WFI analysis on every construction we look at with Airtight. This allowing to see whether we can actually remove the VCR totally out of the construction. Our BIM object library is vast, and independently run BIM objects are available on our website, along with our performance specifications for all our products. With Airtight, on-site toolbox talks and training is delivered before every project starts. This again allowing us to work with the team that are installing the product, making sure they understand what they're doing and how it works. Product guides, Airtight brochures are all available on our website, downloadable, along with our other solutions for the construction industry.
Good afternoon, everyone. My name is Keira Proctor and I'm the Managing Director here at the A. Proctor Group Limited. First of all, I'd like to welcome all the webinar attendees. I hope you find it very informative and an interesting topic to learn more about. Thanks also to Adam Taylor, who's our Business Development Manager for Commercial, who put this webinar together earlier today. He now joins us live from Bristol, actually. I'm here at head office with the rest of the team who put the webinar together in Blairgowrie in Scotland. And Adam is happy to answer any questions you may have relating to the webinar and this topic. And of course, any other inquiries or queries can be asked via our sales and technical office. Details are on our website of that. If you have any questions, we already have some through email and I think some are coming through on the chat now. Please type them into the chat box on YouTube. I believe you have to sign in to make sure that you can actually post the questions for Adam to be able to answer. So welcome, Adam.
Thank you very much. Good afternoon.
Good afternoon. If I start with a couple of the questions that we received via email, I know that a couple of attendees who sent them are online. And then, as I say, we can move on to any that come through via the chat facility.
Perfect.
The first one we had was, how does Airtight compare to EPDM flashing in terms of fire resistance? Can swapping Airtight into the construction improve the fire performance compared to EDPM?
It's a great question and something that's really being looked at the moment for the calorific value within facades and high-rise. By limiting the amount of EPDM across the construction, EPDMs naturally, because of the rubber material, are normally a significantly higher classification for fire. So by limiting the amount that we use, sees a significant drop in the calorific value of the facade.
Okay, good. You mentioned that Airtight allowed reductions in air leakage results using calculations. And what this individual is asking, is that down to the performance of the membrane or is it more about the self-adhered installation method?
Again, it's a great question, and it's actually, I would say, to do with both. The membrane itself is a very good airtightness level. There is a lot of membranes on the market that classify themselves as airtight, but by adding the self-adhesive factor to it and allowing it to adhere to the building, what you end up is not reliant on tapes, and certainly joints within tapes can be moved in high-rise. So material starts coming off the side of the building. By having it fully adhered, you're actually going to significantly increase the airtightness.
Okay. Another question that came through in the chat, which is quite similar to this, regarding the Airtight, from Gary Thompson. Does self-adhering deliver any benefits with regards to watertightness?
It does, for the same reason. Basically, when you look at taping material, basically, if there's any wind movement, you can end up with wind washing, where water tightness will creep in around the joints of the in between the tape and the membrane itself. So again, we've seen a significant difference, and construction time has been decreased based on the building being watertight quicker by using a self-adhered product.
Okay, good. And again, another question, sorry, about the Airtight. Tom Fisher, is the product suitable for high-rise off-site construction? I think you covered this briefly towards the end of the webinar. And would we see the same type of benefits or kind of benefits?
Absolutely, and with Offsite, again, it's an upcoming market that we see a significant difference in delivering with Airtight. Based on that the application is done in factory offsite, and by being fully adhered, allowing transport to move those pods, if you like, on the back of trucks with a watertight line already there, and with the pods coming together, it's all about the application that we offer and the junction details and everything else that we can achieve.
Okay, I have three further questions which we had earlier, which are all regarding the application, Adam. Yep. First one, when applying Airtight horizontally, therefore not being able to start at the bottom of the building, how can you detail the shingle effect so you won't see the risk of water ingress at joints?
Yeah, again, a great question. It is all about site application, and this is the benefits of these products and what else we offer as a package. There's two ways of doing this. One is with a liquid applied breather membrane, which we manufacture to suitably seal this edge. So basically it comes in a 800mm sausage, and you can either bead it or spatula it over the joint. Or another version is our split liner tape, which is a little bit more further in, but it's available on our website to look at for further detailing.
Okay, so a breathable liquid applied solution, and obviously the Airtight in the split liner version, which is quite easy for application.
Absolutely.
Okay, good. And then the two further ones about application. It says with Airtight, presumably you're positioning the membrane against the sheathing board. And I think they're asking, would you not want to see this in front of the insulation in some cases?
Yeah, and it is a good one for the market to really understand that position of membranes. We get asked a lot where that position is going to be the strongest for the building. Some are concerned about membranes getting damp or wet under construction. But if we look at independent advisors like the CWCT, they would advise that the membrane always goes against sheathing board. The changes happen when theoretically you've got an open jointed system, and if you've got an open jointed system, then you may want something that is UV stable, and we've moved forward with an alternative product. So you wouldn't use a Airtight there, but if you'd like to go over to our website and look at Fire Shield. Fire Shield is relevant for an open jointed. It's a carbon impregnated face product, which basically slows the spread of flame within that cavity as well. So it's a really interesting product for that position in the market at the moment. Okay.
A question's coming from Elizabeth Hayden, which I think is relevant to the last one regarding, you mentioned how water or certainly damp can affect the membrane. What she's asking, which is a good question, are there any problems if the substrate becomes wet?
It's a great question, and we've got many cases where we've been running and installing the product not just onto sheathing boards, but also onto concrete and steel. Over the winter months, we had a project down in Portsmouth, which was open all over the winter of 2017-2018. What we found is actually, as you apply the membrane using a roller, certainly in the colder months, what we saw was the ingress of water. As long as there's not water physically running down the sheathing boards, then you're absolutely fine to apply it. And it's pretty much the same if you think about a standard breather membrane application. You'd actually be trying to tape it to the same substrate. So theoretically, if you're struggling to tape a mechanical fix, you'd be probably struggling to tape a fully adhered. So you wouldn't do either anyway in those kind of conditions.
Mm-hmm. And I think it's fair just to add to that, Adam, one of the main benefits of the product, because of the highly breathable nature of it, there's an element of drying out. So the substrate, not only are you adhering on an airtight solution, because of the high vapor permeability, obviously it does allow that substrate to dry out, which is one of the main benefits.
Absolutely, and that's what we've seen across the construction. You know, we've seen certainly buildings open to the elements, and the drying out periods have been increased. Mm-hmm. So you see that movement of vapor coming out of the building better.
Okay. Last question that we had via email about installation. How is detailing around larger penetrations like steels, etc.? Do you tape this, or is there a different method?
That's a great question again. And when you think about tapes, and we mentioned wrap-tight tapes, basically wrap-tight tapes is actually a full membrane, just cut into smaller rolls. So you're not using a tape that's non-breathable. So even with detailing around those junctions, you're still using something that's breathable. And when we think about steels, they're normally a cold spot. So you've got more risk of condensation. By using a tape that's breathable or our liquid flashing, it's still allowing that condensation to move out of it.
Okay. Just bear with me. There's one here there is one more question. Sorry, Adam, I'm speaking to the microphone regarding installation in wet conditions. But what Aid Whitefoot has also asked is, do you anticipate or have we had any problems with installation during cold conditions?
No, and again, a great question. It's about site application, and as part of the offering from a Proctor Group is that we do site installation guidance and toolbox talk training, and along with those, we'll look at the kind of weather conditions that the membrane is going to be applied. What you'll find is because your substrate is warmer in the summer and the product is warmer, then theoretically you can use a brush to brush the membrane onto the surface. In the colder months, we recommend using a rubber roller, and that allows you to get some friction between the substrate itself and the product. That just warms the adhesive up a little bit more to get the grab that's better, but we've certainly not seen any problems with it in the colder periods of time.
Yeah, I mean, from obviously just knowing myself where this product is utilised, it's been used in Alaska, certainly in extremely cold conditions, and obviously we have all the testing required down to, various service and installation different degrees, which we could share with individuals to again show confidence, and then it can be installed in different types of temperatures and environments, obviously.
Yes, absolutely. And that's the key thing. It's about the testing that we do to these products to allow us to move them into the market.
Good. Okay. I'm not seeing any other questions coming through. So I think we'll wrap it up there unless you have anything to add, Adam.
No, and again, our details are on the website. Please feel free if you'd like to follow up with anything following this video, following the webinar, then please let me know.
Yeah, absolutely. And just in addition, we will be sending out via email, when you registered for this webinar, we will send out a copy of a link to the webinar. Feel free to circulate it if you have colleagues who may be interested, or other colleagues, for example. In different businesses, we have no issue with it being circulated wider. That link will also come with a link to a survey, or shortly afterwards there will be a survey sent. If you can take time to fill this in, we really appreciate it, because what that does, it allows us to shape how future webinars are to make sure that the audience is getting what's required, i.e. they're at the right time, we don't talk for too long, the information is relevant. So any feedback, positive or negative, is always taken constructively, and we'll then try and apply that to our future webinars. So thank you all very much for attending. It's very much appreciated, and enjoy the rest of your Valentine's Day, I should say. Thank you very much.